Hey guys, this is Suman Gupta, online math tutor, and I welcome you to my channel Celestial Tutors. Today in this video, we are going to learn the very first topic of AP Calculus, limits and continuity. So let us learn how limits help us to handle change at an instant. The concept of limit is fundamental in understanding instant change. Limits help us to find slope of curve at some specific point representing instant rate of change. To learn about instant change, first we talk about average rate of change. For that, let us take an example of this graph. We need to find the average rate of change of this curve on this interval x1 to x2. I hope you all must be familiar with the slope formula. We use this slope formula to find the slope of a straight line. And the similar formula is used to find the average rate of change of a curve on some interval. In that case, we can write this formula as average rate of change equals f of x2 minus f of x1 over x2 minus x1. Here f of x2 and f of x1 are nothing but just the y values, just the outputs at those points. To find the average rate of change of this curve on this interval, let us draw a straight line passing through these 2 points, and these are the corresponding y values. This is f of x2 and this one is f of x1. Using this formula for this curve will give us the average rate of change on this interval for this function. If we make this interval more small, say these points are x1 dash and x2 dash, this interval is made more smaller and another secant line is drawn. This line passing through these 2 points is called the secant line. So another secant line is drawn passing through these 2 points, and that gives you the average rate of change on this smaller interval. When we keep on drawing the lines, making these intervals smaller and smaller, at last we will reach a point when this line would be a tangent to the curve. Look at this green line. This would be a tangent to the curve. It will touch the curve only at a point. It won't intersect the curve. Instead, it will only touch the curve at some point. This would be the point of tangent. Say this is point A. Now this green line is touching the curve only at a point. And this way the average rate of change gets turned into instant rate, because this green line represents the rate of change at that moment, at that instant, when x is equal to A. This green line will give you the instant change, and the rest of the lines, the red line and the blue line, will give you the average rate of change, AROC. So here we can see that secant lines gives you the average rate of change over an interval, whereas the tangent line gives us the slope of curve at that moment, at that instant. Now let us see how this instant rate is represented using the concept of limit. Look at this example. This interval has a width of h, and if we make this interval very small in such a way that both these points, the point A and the point A plus h, they are very close to each other in such a way that we can't see them separately. It seems they are just overlapping each other. In that case, this distance h would be very small, that this is approaching to 0. We almost assume it as negligible distance, such that this is approaching to 0. And then we define this instant rate of change using this concept of limit. Here we write limit h tends to 0. That means this interval, this distance is approaching to 0. It's becoming very small in such a way that it is almost 0. In that case, the difference between these two outputs, the difference between f of A plus h and f of A, would represent the instant rate of change, IROC. For example, we need to find the instant rate of change when A is 2. Let us assume this distance h very small, like 0.0001. So in that case, this would be 2 plus 0.0001 minus f of 2 divided by 0.0001. So you can see this distance h is very close to 0, and in that case the output between 2.0001 and f of 2 would represent the instant rate of change. So this is how an instant rate of change is represented at 2. Let us look at this example to understand this concept better. The height of a raspberry bush can be modeled by the function h, where h of t gives the height measured in feet and t gives the number of weeks it was planted for 0 to 12 weeks. The graph of the function h is shown to the right. For the first part, it says to draw a tangent line at 9, at t equals 9. We know that tangent line is the line which just touched the curve at that point. So this is the tangent line at 9. And for next part, it says give the rough estimate of instant rate of change at 9. To get the rough estimate of instant rate at 9, we just divide the y value by the x value. The y value is 1.5 and the x value is 9. So we just divide them. 1.5 divided by 9. That gives you approximately 0.16 feet. So this gives you the rough estimate about the instant change. And for the next part, it says give an example of how to calculate the rate of change that would give a close estimate to the instant rate of change at 12. To get the close estimate of instant rate of change, we choose a point which is very close to 12. Let us say this is 12.0001, and then we apply the formula where the distance h is 0.0001. After calculating the value of this, you will get the close estimate of instant rate of change. Here is the next similar example. A dam has a dam release that releases water. The amount of water released can be modeled by V, where Vt is the volume of cubic liters of water and T is the seconds since opening the dam release. So T is the time represented in seconds and V is the volume of water in cubic liters. First part says what does V of 100 represent? We know that V of T represent the volume of water after T seconds. So when it say V of 100, that means volume of the water released from the dam after 100 seconds. For the second part, look at this interval. This interval is 0 to 100, which is a significant interval. It's a quite long interval. That means this would represent the average rate of change of the water released from the dam during the first 100 seconds. So the second part represents average rate of change, AROC. Look at the third part. Now observe these 2 points. These are very close to each other and this interval is very small. These 2 points are very close to each other in such a way that the distance between them is almost negligible. The h value is almost 0. In this case, this will give you the instant rate of change at the 100th second. So we write it as the rate of change of water released from the dam at the 100th second, at that moment when the time was 100 seconds. So you can easily observe here the interval was significant. So this gives you the average rate of change over this interval, and here the interval is very small in such a way that both these points are very close to each other. So this gives us the rate of change at that instant when the time was 100 seconds. So this gives us the IROC, instant rate of change. I hope you have understood the concept of instant change by now. Don't forget to share, like and subscribe my channel. Stay tuned for next video. Till then, take care. Bye bye.